Hello, I'm Anna Mackay and this video is on sketching quadratic graphs by completing the square. So we've got two examples to demonstrate this. If we have to write this quadratic in the form of y equals x take h all squared plus k, which is the turning point form, then we need to complete the square to that standard quadratic. And once we've done that, we're going to sketch it and state the coordinates of the vertex. So this is a bit of a refresher on completing the square. So you write out your quadratic and then, part of it, and then you look at the b term. So knowing that a is the coefficient of x squared, b is the coefficient of x. And what you have to do is you have to halve that, so half of 4 is 2, and square it. Now you have to add it on and subtract it off, because if we've added on 4 and subtracted off 4, we've essentially done nothing. So we haven't altered it at all. And then put that final constant on the end. Now it's always best not to work out that 2 squared, leave it as the 2, because that now helps us when we come to complete the square, so to speak, because we have x plus that 2 number. To work out the constant on the end, you work out that, so -4 plus 3 is -1. So that's now in the form that we need. Go back to the question, read what it asks. It says, hence sketch it. And state the coordinates of the vertex. We could state the coordinates of the vertex now. Remember that it is the different, sign for the x coordinate of the vertex, -2, but you keep the sign for the y coordinate of the vertex. Sometimes it's handy to think of where has that shifted from. Our standard quadratic graph is y equals x squared, which goes through the origin and is concave up. This, with -2, -1, means it shifted 2 units to the left and 1 unit down. Well, what has shifted? Essentially everything, but it's that turning point has shifted to the left and down. And it's also very handy to know what the y-intercept is there, but you don't need to worry about working it out from here. Go back to the very original, and we know that that constant number on the end is our y-intercept. So our y-intercept is 0,3. Sketching that graph, we obviously using a ruler, unlike myself here, arrows on the end of your axes, label x and y, and think about what points that you've got. For our vertex, we have -2, -1, so that's going to be -2 over here and down 1, -2, -1 for our vertex. Put a dot. And our y-intercept is the other really handy, quick and easy one to sketch, up at 3, and then we're going to sketch the parabola. So we have to turn at the vertex. I sometimes quite like to put the turn in first to know where I'm headed. We don't know what the x-intercepts are here, so you just cut it through wherever it cuts through. You might want to think about, though, how many steps over it came to line up with the y-intercept. We talked about it being a shift of 2, so therefore the point that's going to be approximately up here has to be as high as 3. See if that sort of makes sense when you've shifted over 2 to the left this time around. So something like that. Arrows on the end, and it's always good form to write what is the name of that line, and the name of it is its equation. Okay, one more. Converting this quadratic to the turning point form. And how do you do that? You have to complete the square. The tricky thing about this one is that, we have the a, the coefficient of x squared, isn't 1, it's 3. To complete the square, we need the coefficient of x squared to be 1. So you have to factorize out that 3 first of all. So let's practice doing that. We've got y equals 3. Always handy to use a square bracket for this one. Now, dividing each term by 3. Please don't just divide the x squared term by 3. You must divide everything. Yes, I know it's fractions and that's a bit awkward sometimes. We'll just take it slowly. Now, we have to complete the square. So you have to look at this b term and halve that. Start to think about what that's the half of 4/3 is going to be. So we're going to add on, dividing that by 2, you get 2/3 all squared, and then you subtract off 2/3 all squared. Remember, leave that as 2/3, don't work that out. because that will come in handy for when we complete the square and turn it into the square factor. So we have x and 2/3. Now I ask you, is it going to be a positive sign here or a negative sign here? What determines that? Well, you look at the b, the coefficient of the x term there, and it would be a negative here. Maybe I'll just even do that in red. And finishing it off, you now work out the constant term here. Here's one I prepared earlier, -1/9. And now, to read off the vertex though now, please don't think that it's 2/3 and -1/9, because that's sort of in the form. It has to be in this form here. You have to expand in that 3 that you have out the front. So don't be caught by that. So expanding out here, and therefore 3 times 1/9 gives us 1/3, well, -1/3. So our vertex here, we can read off, you can write vertex or just V is fine, and -1/3. And our y-intercept, again, don't look at this for your y-intercept, look back at the very original one, because then you're essentially substituting in x is 0, they disappear, and you're just left with 1. It can be very tempting just to look at this part here, y-intercept of 1 or 0, 1. Now we're going to sketch that. Here's one we've written out neatly. Here's our vertex and our y-intercept. So thinking about, it's always handy to think about where you need that Cartesian plane, if you like. Do you do it even quadrants or not? Think about our values here. We've got thirds, so they're quite small, quite close together. We've got minimal negatives there, so we don't need to have it deep, nor do we need it particularly high. So that might help you ascertain how and where you draw that. Perhaps something like this. Label the axes x and y, putting arrows on them because they extend past that. Any scale, no harm in using a scale of thirds if you like. And down here, well, and your scales can be different actually. Okay, so our vertex, 2/3 for the x, so this point here, and -1/3 for y. V is equal to 2/3. Sorry that my V looks a bit like a U there. And so we have a dot there for the turning point. The y-intercept is 1. Because I'm using a scale of thirds, I better have 3 components there. And I often like to think about where's the equivalent point going to the right-hand side. So it would be about there. Sometimes it's easier to connect the dots when sketching. I often quite like to put the little curve in first. Helps me work out where I'm going. And completing that, arrows on the end because it continues past that point, and write the function. You can write it in any format now if you like, completed the square format or the original quadratic there. Okay, whoops, so we're done, and the next video is still in this same section about sketching graphs, and it's just sketching them directly. Subscribe to the channel. Thank you.